Hey, what's going on, guys? In this video we are going to talk about Fermi level of intrinsic and extrinsic semiconductors. Now let's look at the definition of Fermi level. Fermi level can be defined as that energy level which has 50% of probability of occupation by an electron at any temperature. That's the definition for Fermi level. Now let's look at the intrinsic semiconductor Fermi level. For an intrinsic semiconductor, number of electrons in a conduction band is equal to number of holes in the valence band. So number of holes and number of electrons in the conduction band, C band, is equal to number of holes in valence band. Okay. And in another way, we can say probability of finding electron in conduction band, probability of finding electron in conduction band is equal to probability of finding holes in valence band. So when this happens, what's going to happen is our Fermi level is going to be exactly in the middle. When they are equal, we are going to have the Fermi level that is exactly in the middle for intrinsic semiconductors. Now for extrinsic, it's going to be different. So let's look at the extrinsic. For extrinsic, there are two different cases. We have N-type semiconductor and P-type semiconductors. Now let's go ahead and draw the diagram for that one. So for N-type and P-type. Okay, so this is our N-type, and let's say this is our P-type. Okay, let's write this one down first. This is N-type, and this is P-type. Okay, for N-type, the conduction occurs mostly due to electron. So it means when we have higher electrons, it moves toward the conduction band. Here let's compare the relationship. When the electrons are high, the Fermi level goes up. So FL will goes up. When the holes are high, the Fermi level will go down. So that's the relationship. Now for N-type semiconductor, the conduction happens due to electrons. It means it has higher electrons. So if the electrons are high, the Fermi level goes up. So the Fermi level is going to be somewhere here. So this is our EF for N-type semiconductor. And this is conduction band. And this is valence band. Same thing for this one, conduction band. And this is valence band. And this is energy band. And here this is energy band. Now for N-type, our Fermi level is right here. This is an energy level, and that is near to conduction band. So in other words, we can say probability of finding electron in the conduction band is higher than probability of finding holes in the valence band. This is for N-type. Now for P-type, the conduction mainly occurs due to holes. So it means the Fermi level is going to be going down. When the holes are high, the Fermi level goes down. So we are going to have the Fermi level somewhere right here for P-type. So for the P-type, in other words, we can say probability of finding electron in the conduction band is lower than probability of finding holes in the valence band. So these are the basic comparison we can make for intrinsic and extrinsic semiconductors by Fermi levels. Okay, let's explain again. For intrinsic semiconductors, both of them are equal. Probability of finding the electron in the conduction band is equal to probability of finding the holes in the valence band. That's why we have this one in the middle. But for extrinsic semiconductors, there are two cases. We have N-type of semiconductor and P-type of semiconductor. For N-type of semiconductor, the conduction usually occurs due to the electrons. It has high electrons. It means the probability of finding the electrons in the conduction band is higher than the probability of finding the holes in the valence band. So when the electrons are high, Fermi level goes up. Because of that, we have the Fermi level on top. And for the p-type, it's opposite. Probability of finding the holes in the valence band is higher than the probability of finding the electrons in the conduction band. So we have the Fermi level right here. And also for p-type, the conduction occurs mostly due to the holes. That's why we have the Fermi level right here. This is EF. And these are some basic stuff. And let's see what is hole is. Hole is basically when the electron leave a space, that one will be replaced with a hole. Like for example, let's say we have electrons like this. So when the electrons leave from here, that place will become a hole. So this is going to be hole, and some electron can come and fill up this space. So this is what we have to know about hole. And that's all about Fermi level of intrinsic and extrinsic semiconductors. I hope this helps. Thanks for watching.